AP Calculus AB, Unit 2, Review, Corrective. So this is some good practice to get you ready for your retest. Should have tried them all already after looking at your last test. This is some good extra practice. So we're just trying to find the exact values here without a calculator. The front is no calculator. The back is calculator. So first thing you want to do is you want to figure out what the reference angle is. Well, I might even write this as 1 over cosine of 330 degrees. So the reference angle is 30 degrees. It's quadrant 4. So the value of cosine, 30 degrees, I've just memorized them. Starts at 1, it goes down to 0. So this is that first small angle, so it's going to be root 3 over 2. It's positive in quadrant 4. So we could rewrite it as 2 over root 3, and then we could rationalize the denominator, multiply top and bottom by root 3, and get our answer. So I'll zoom in here so we can see this a little closer. Next one, this is almost a full circle. 6 pi over 3 would be 2 pi. So alpha is pi over 3, and we are in quadrant 4. Cotangent is cosine over sine. Now, you could convert this to degrees if you really feel like you have to. Pi is 180 degrees, divided by 3 is 60 degrees. That's how I would do it, quick in my head. But this is the bigger angle. It goes from 0 to pi over 6 to pi over 4 to pi over 3. So for cosine, that's going to be 1/2. And for sine, that's going to be root 3 over 2. Now in quadrant 4, cosine is positive, sine is negative. It's going to be negative 1 over root 3. Rationalize the denominator, get root 3 over 3. This one, 570 backwards. So if you add 360, you're going to be at 210, negative 210. And I mean, you can draw a quick little picture. Negative 210, negative 90, 180, 210 would be right here, right? Negative 210. So that's going to be a reference angle of 30 degrees. So alpha equals 30 degrees. We are in quadrant 2, as you can tell from the picture. So sine of 30 degrees, that's going to be 1/2, and it's going to be positive because we're in quadrant 2. All right. Cosecant, so the reference angle is pi over 6, because 12 pi over 6 would be 2 pi. And that'd be quadrant 4. So we're just in the fourth quadrant. Cosecant is 1 over sine. So I always like to write that down. I don't want to memorize any extra values. So sine of pi over 6, or 30 degrees, is 1/2. In quadrant 4, it's negative. So your final answer is negative 2. So got to be able to do those. And be able to solve trig equations. So you want to isolate the trig first. Subtract 1, divide by 2. Reference angle. What angle does cosine equal 1/2? That's 1, root 3 over 2, root 2 over 2, 1/2. So that's 0, 30, 45, 60 degrees. When is it negative? Quadrants 2 and 3. So I like to write expressions for all the possible answers. X equals quadrant 2 would be 180 minus alpha 120 plus 360k. And x equals quadrant 3 be 180 plus alpha be 240 plus 360k. And then we just want the answers from 0 to 360 this time. So 120 and 240 would be the answers. Just got to be careful on these. Now cotangent is cosine over sine. And so you want to think of this as, okay, well, that would be like a negative root 3 over 1, and we could put them over both over halves. So when is cosine root 3 over 2 and sine 1/2? Well, that's 30 degrees. Not when is cosine negative and sine positive. When is either positive and one negative. So that's going to be quadrant 2, sine's positive, cosine's negative, and quadrant 4. So we're going to write 2x equals. Now, here's the deal. It's cotangent, so we could just do the first quadrant and do 180k because the period of tangent and cotangent is 180 degrees. So that'd make it quicker. So quadrant 2 would be 150 plus 180k would take care of all the answers. You could do 360k and the other 360k. But this would save you a little bit of work. Divide by 2, 75 plus 90k. So 75, 165, 255, 345. If you do quadrant 2 and quadrant 4 with 360k, you should get the same answers. All right, and then we have some trig inequalities. So we got to find the roots. So very much like the work we were just doing, but then you have to do a line check. So we're going to say sine of 2x equals negative 1/2, and cosine of 3x equals 1. Reference angle is 30 degrees. Quadrants 3 and 4 are where sine is negative. So I'm going to do 2x equals, quadrant 3 would be 180 plus alpha 210 plus 360k. And then the next one is going to be quadrant 4 would be 360 minus 30, so 330 plus 360k. And then we divide by 2. And we're going to get x equals 105 plus 180k. And x equals 165 plus 180k. And so we're going to have 105, 285, 165, 345. These ones right here, cosine equals 1 at 0 plus 360k. And so then we divide by 3, and we get 0. We get x equals 0 plus 120k. Now, these are going to bounce off the graph. Sine and cosine equal plus or minus 1 is going to bounce off the graph, so we got to make sure we keep track of that. So we have 0, 120, 240, and 360. But those are all going to bounce off the graph, so don't lose track of those. So we're going to do a line check. Set up a line check. The little barriers here. So 0 is actually a dot. These are all solid dots. 0, 105, 120, 165, 240, 285, 345, and 360. Make sure you put them all on there, left, right, in order. Now, which ones were they? This one's going to bounce. This one's going to bounce. This one's going to bounce. And that one's going to bounce. See if that makes sense. Yeah. So test a value. Tell me what you're going to test. I like test 0, but I can't this time. So I'm going to go for something easy that if you double, it's a nice thing like 45. It's 90. Sine 90 is easy. That's 1. So that's going to be 2 times 1 is 2, plus 1 is 3. Cosine of 90 is 0. So it's going to be 3 times negative 1 is negative 3 is true. So 45 is true. It's going to stay true on both sides there, and then false, stay false on both sides, then switch back to true, stay true on both sides, false, true, true. So I'm going to darken in the answers. Now these are solid dots, so we're not going to have to break them up. So the answer is going to be 0 to 105, brackets. 120 is an answer. These should be left to right. 165 all the way to 285. And then 345 to 360. There you go. Interval notation. Show your work. Nice and neat. Be organized. Best way, best plan attack. Okay, number 8. So cosine squared x equals, you could subtract 1, divide by 2, so positive 1/2. I'm ignoring the inequality. I'm going to take the square root of both sides, plus or minus. So we're going to get cosine x equals plus or minus root 2 over 2. So alpha is 45 degrees, and we're in all the quadrants, 1, 2, 3, 4. We could take advantage of that, or not. You could do quadrant 1 plus 360k, 2 plus 360k, 3 plus 360k, quadrant 4 plus 360k. You could write 4 expressions. But if you're observant in this very special case, 45, the next one's 90 away, 90 away, 90 away, because it's 45 and all the quadrants. So the shortest way would be 45 plus 90k. You can get all your answers from that. Otherwise, you could do x equals 45 plus 360k. We do x equals, quadrant 2 would be 180 minus 45, so it'd be 135 plus 360k. Quadrant 3 would be 180 plus that. That's going to be 225 plus 360k. And quadrant 4 would be 315 plus 360k. Now, this should give you all the same answers. 45, 135, 225, 315. Same answers. A little less work. But don't use it unless you understand it. Okay. So we're going to do our line check. 0. These are going to be open dots. 45, 135, 225, 315. Close at 360. This time I can test x equals 0, so I'm going to go for it because there is no root there. If I plug 0 in here, cosine 0 is 1, 1 minus 2 is -1, is less 1 is true. True, false, true, false, true. So this goes through those endpoints, but we're going to cap our answers at 0. One of the reasons I write that little bracket there. These should be parentheses. That one's going to be bracket though, because it doesn't end there. It keeps going right through it. So watch out for that kind of answer. So bracket on this end also. But the other ones are parentheses because those are where the roots are, and they're not equal to. All right, 9. Move it all to one side, just like we did last chapter with polynomials and rationals. Factor it. This has the form of like a quadratic trinomial. So I'm reverse foiling it. So I mean, this one doesn't have a whole lot of different possibilities. So I know that it's got to be 2 cosine and cosine, and 1 and 1. One's going to be positive, one's got to be negative. This one's going to be negative, this one's going to be positive, so that you get that negative right there in the middle. So then cosine 2x equals -1/2, and this one cosine 2x equals 1. So here, alpha equals 60 degrees, quadrants 2 and 3. So we're going to do 2x equals 120 plus 360k, and 2x equals 240 plus 360k. These guys are going to bounce off the graph. So 2x equals 0 plus 360k. So x equals 0 plus 180k. So x equals 0, 180, 360. Those are all going to bounce off the graph. These guys are going to divide by 2. So we get 60 plus 180k. And 120 plus 180k. And so it's going to be 60, 240, and 120, and 300. And we expect to get twice as many answers as normal because the 2 cuts the period in half, makes everything happen twice as fast. So line check here, you can have room. These are all going to be solid dots. So solid dot at 0, solid dot at 60, solid dot at 120, solid dot at 180, 240, 300, 360. But watch out, this guy's going to bounce, this guy's going to bounce, this guy's going to bounce. I'm going to test the value, can't test 0, so let's pick something good. 45 would be good because cosine 90 is 0, so it's going to be 0 is less than 1, which is true. So true stays true, false, true stays true, false, true stays true. The answer is 0 to 60, brackets, 120 to 180, brackets, 300 to 360, brackets. You should probably put the degree symbol without a unit on angles that is assumed they're radians, which is not what these answers are. Now looking at this, let's see. Oh, I made a little mistake. It should be a 240. Don't break that up because it's solid dot. If it's open dot, you have to break it up. So there you go. A little special right triangle. Picture may not be drawn to scale, so don't just assume because it looks like 45, it is 45. AB equals BC, so those are equal. CAD is 15. Okay, and AC is 12. Okay, now this is a right triangle with equal legs, so it has to be an isosceles right triangle. That means these angles have to be equal to each other, which means they got to be 45 because it all adds up to 180, and there's a 90 already in there. So this is definitely 45, 45, 90. The legs are equal. The hypotenuse is the leg times root 2. So to work backwards, it's going to be the hypotenuse minus root 2, which if you want to rationalize the denominator is going to eventually give you 6 root 2. So this one's 6 root 2. Now, 45 and 15 together makes 60. So you see the big triangle here? That's a 60, 90. This has to be a 30, which also means that this has to be a 135 here. So I'm just finding everything I can just in whatever is the easiest. Now we're going to probably have to work off this guy. This is the short leg of the big 30, 60, 90. So the hypotenuse is going to be 2 times the short leg. And then the long leg is going to be short leg times root 3, which is going to give you 6 root 6, which makes the length of this line right here going to be 6 root 6 minus 6 root 2. I think we've pretty much found everything on there. So AB is 6 root 2. BD is 6 root 6. AD is 12 root 2. The angle ACD is 135 degrees. The area of ACD, that's this triangle, would be 1/2 base times height. Well, I would probably use that as your base, 6 root 6 minus 6 root 2. And the height I would use over here, 6 root 2. We just need to simplify this. So if we distribute this, we get 3 root 6 minus 3 root 2. And then we could distribute this into there, and we're going to get 18 root 12 minus 18 root 4. Then we could take the square root of 4 out of this. So that's going to be a 2. It's going to be 36 root 3. And that square root of 4 is 2 here, so that's going to be minus 36. So your best simplified answer is going to be 36 root 3 minus 36. My best advice is to find all the sides of an angle in the triangle before you even start trying to look at what your questions are, because you're probably going to have to find them all anyways. And it's just quicker that way. Sketch these graphs. Okay, so this is a sine graph. Mark off the period, cut it in half, cut the halves in half. 1, -1. We're going to sketch the parent function. So sine starts here, 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 and here. Light dashed line. it is usually 2 pi 360. But there's an extra pi on the inside, so that divides the period by pi. So the period is now 2 radians, or 360 degrees. The negative flips it backwards, flips it across the horizontal. And so then I want it back in the positive region, so I'm going to bring it back in here. So a negative on the inside sine actually has the same effect of a negative on the outside sine. That doesn't happen for cosine, by the way. 2 is going to double the height of everything. So that means this dot goes down here, this dot goes up here, and this would be your final graph. And we're going to mark the max and the min values. And there you go. That's your graph. Show your work. Okay, next one. I'm going to start with cosine. So mark period off, cut in half, cut the halves in half, get quarters, 1, -1. Cosine starts here at 1, 0, -1, 0, 1, light dash line. Period is 2 pi 360 for the parent function. I'm going to divide it by 3 to get the period in radians and degrees. Next, the negative flips it over here, which, by the way, looks exactly the same as if we didn't do anything to it. The 2 multiplies all the values by 2, the height. So that's going to give us a new graph. Light dash line. The negative in front of the 2 flips it upside down. So now these are all going to get flipped upside down. And then the plus 1 moves everything up 1. So that moves up 1, this moves up 1, this moves up 1, this moves up 1, this moves up 1. And your new graph looks like that. And then the absolute value is going to flip any of the negative parts and make them positive. So this flips up to here, this flips up to here, and the graph is going to look like this. And it's going to, the curve should be smooth at this point, going right into this. And then this part gets flipped up, and you get this sharp corner right there. But it's concave down, it's concave up over here, concave up, concave down. Mark the height, the max, and the min. The min is at 0. That's 1 period worth of graph. Okay, number 13. Mark the period, cut in half, cut the halves in half. So the sine curve starts here, 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 here. Oh wait, here, here, here. The period is generally 2 pi 360. It's going to get divided by 2. So the period is pi 180 degrees. Now we got to factor the 2 out of this to get the right shift. That's a horizontal shift to the right, pi over 2. Now remember, this is pi, so pi over 2 is right here now. So the whole graph gets shifted to the right that much. Now, if it's kind of an ugly shift, then I'm okay with you saying, okay, well, I'm just going to do my graph right there for the period. But this one works out really nice, so I think it's really easy to back it up and just start it there. The 2 multiplies all the y values by 2. So I'm trying to remember where we're at. We shifted it, so it kind of has the look like it's upside down now. And then the minus 1 shifts everything down 1. And so that's your new graph. And then the absolute value flips the negative part up. So this is going to go all the way up here to 3. And this is going to be here. And this is going to be here. So it's going to look like this. So it's like this. And then the minus 1 moves everything down 1. Oh my gosh, this is a crazy graph. Be careful. That moves down. This moves down. This moves. Oh, hold on. This part gets flipped up over here before this step. And then they all move down. So the graph's going to look like that. That. So the max is 2, the min is -1. That's one period worth. It doesn't quite match the picture I have. Did I make a mistake? Oh, let's see. So we start with sine, and then we had the upside down version, right? Because of the shift. And then everything got moved down 1. We got multiplied by 2 first, and then moved down 1. And then the absolute value flipped this part up here, and this part up here, and then we shift it all down. This looks right. On mine, well, mine on my solutions looks right too, except I just started it right here. So if you did that, then you'd have this portion of the graph over here. So it's either this or it's this. All right, I'm gonna do the other side in a separate video because this video is getting long.